We're going to talk about architecture and architecting systems because that's what I do. And it'll give you a little bit of an introduction. And this is really can only be in the time that we have. It's a little amuse-bouche, a little appetizer of the subject, something we'll get more deeply into AdaConf. I'm also doing a workshop the day before if you really want to come have fun and play with some of these concepts. So I um, I've been really fortunate in my career to get to do difficult things. I started as a back-end engineer, and one of my early projects was the Wikimedia Foundation needed to take credit cards. Go. And I wrote a lot of PHP code. I get up in the morning and throw up because I was afraid that I was going to bring down all of Wikipedia. My teacher friend said, please do. My students will do their homework if you do. But it all worked out fine. And then over time, I became someone that would come to mind when an organization was making a transformative change in their technology system, right? When they were changing not just a piece, but the system. And so I'm asked to architect change. And the biggest part of my work is often invisible. One of the reasons I wanted to focus on this today with us is because it is something that is more visible if you have a lot of life experience that is somewhat invisible in the broader system in which you live, which is why I think it's important that there's more of that in the design of systems because it brings a valuable perspective. So at the start of my relationships with systems, this is me in the doorway. You might know this feeling of being this person in the doorway. And then sometimes at the end, that's also still me. That our approach to architecture, even when it's transformational, has largely mirrors the industrialized way. So Taylorism in the US, scientific management, has had a lot of impact on the way that we work. And that the system that we worked in had a very strong point of view about who did the work, who managed the work. The challenge is if I approach it in a linear way, rational, top-down, procedural, predictable, concerned with control, I'll fail and they'll fail. This absolutely has to be part of the process, but it isn't the embodiment of the process. Because as Pirsig, I think, says this best, that if a factory is torn down, but the rationality which produced it is left standing, then that rationality will simply produce another factory. This is the first time my team and I went from monolith to microservices. And then 3 months later, our microservices are very tightly coupled. Well, of course they were, because our brains are very tightly coupled, right? We thought in a MySQL CRUD software way, and it took us a while to figure out how to think differently. And so this linear and industrialized approach to production is part of what needs transforming. In other words, the call is coming from inside the house. This is generally not what as teams and as organizations, this is generally not what we expect when we start making a change in how a system works. And so the call is coming from inside the house, but we don't look there. We don't start there. We don't begin by cultivating organizational self-awareness. We go shopping for silver bullets and solutions to the pain. This is why I give a lot of talks called Architecture is Not Kubernetes. And I do not mean that Kubernetes is a problem or not part of it. I mean that it's not the whole. Kubernetes represents a pattern change, an orchestration change in the system. And I do this too. I will always try and look for something I can buy or adopt that will solve a complex problem in a very simple way. It's a very human thing. It's also a good place to start. If the answer is Kubernetes, that is what should happen. So my snark is that we need a transformation, so we built a scaled agile framework, because I hear this a lot. Safe is the answer. So we don't look at how the system itself is generating the result. And Deming says that every system is perfectly designed to get the results it gets. And in systems, one of the ways that I really like to explore this is using the iceberg model, which shows when you think about the patterns and the structures and the mental models underneath events. So for example, I've modeled this with groups, with DDD groups about an outage in production. And it's very interesting how we're being asked to do too much work too fast without being able to think about the impact is one of the things that comes up every time we think about this. And now the outages in production are connected to many aspects of how we work. And so architecture, to some extent, always is going to include changing the mindset out of which the system's goals, power structures, rules, and culture arises. And so that's why I like to talk about this, because it's a surprise for me. I just wanted to write code and build things and make things go. And over the years, I've come to realize that this is the part that is the hard part. That the tech, as hard as it can be, and it often is quite challenging, this is the part that will enable me to, and all of us to have an impact. Or the joke I make is at the end, everything gets rewritten in PHP. And a product manager I did a talk with, hers is, and we never end up moving off the mainframe. I'm sure you have your happily ever after not ending that you've seen again and again, where regardless of the amount of energy put into a change, there's an inevitable ending that is pretty much looks like the beginning. This doesn't make me popular in meetings, that this is my focus, but actually it depends on the meeting, because it does among the people who are trying to make the change. So even if we knew better, even if we understood the system is designed to do what it does, the call is coming from in the house. So before we try and solve a problem by inviting McKinsey to come and give us 700 PowerPoint slides, and then we'll just do what they say, we'll see how we might be part of this outcome so we can figure out what needs to change. Even if we did that, we would still struggle. And the reason that we would struggle is because in systems, there is one thing that happens more often than anything else. And that is that we have a lot of ideas about why things are happening the way they're happening. And they always involve blame. And when humans face complexity, we blame. This is how we try and explain it to each other. This is a very well-studied natural occurrence. Unfortunately, the vast majority of the time, we're blaming the wrong things. We blame the users, we blame other teams, we blame engineering. If you're in engineering, then you blame product. Everybody blames architecture. We blame the monolith as if we didn't build it. We blame legacy code because we didn't build it. That was some guy before us. We blame Agile. This is the favorite one now. Apparently, climate change is happening because Agile. Like that's how up level this has come. We blame leadership. That's always we blame leadership. My new personal favorite is the deep state. When Twitter went down early on, was doing an interview, a big interview. This was Musk's reason for why it went down. And so this is my new favorite. If there's a bug or anything, then it's the deep state. So we don't have a deep state, we have a deep structure. It's the accumulation of decisions and defaults and unwritten rules that are guiding us, and often we don't even notice them, right? So blame is how we avoid architecting change, not how we implement it. And there was one group that was playing the beer game, which is worth Googling at some point for how that gets played. It was invented as a systems learning exercise. And at the end, there's all the blame on the different teams. One of the guys said, I guess it doesn't make sense that all the stupid people ended up on the other team. And I thought, I wish I knew that at the beginning of my career, because I cannot tell you how often I've come to the conclusion that one other part of the organization is where all the stupid people are. And so I am not suggesting we just hug it out, that we could all get along, that it's never the people, because sometimes it is the people, right? Sometimes it's Steve. Steve is the person who shuts down every conversation and every collaboration. Steve says no to everything. In my experience, Steve usually was working on the ops team, but this has actually expanded. Steve believes that only Steve ideas are the right ideas because Steve knows. And the system has created Steve by rewarding 10x kind of approaches and normalizing antisocial behavior. And the Steve problem often gets dumped on the architecture process, which is get Steve on board, be empathetic to how, like, understand where they're coming from. And those are all really important. But about 10 years ago, I started realizing that will be my whole career, and that Steve needs to transform Steve. Steve cannot be my job. So sometimes that is the case, but usually it is something systemic. Personally, I blame Kubernetes for everything, and that usually actually works out. But that would be a whole nother talk. It's great. It has tools. It's just one of those things that has become so overblown that now I like to hate on it. So we blame the wrong thing. And unfortunately, then we do the wrong thing. So this is called counterintuitiveness, that when organizations try to change, because they're blaming the wrong thing, but also we tend to be very proactive. We want to do something. We tend to do the thing at first that makes it worse. So the Phoenix Project, people bring this up a lot when we hear about counterintuitiveness. This is my favorite example, probably the best known, which is adding manpower to a late software project makes it later. If you've had this experience, you know this. You know that we said 6 months, we need it in 3 months. So we'll give you 4 more engineers and then you'll be able to do it in twice the time, right? Like, we know that that doesn't work, but you can see why it would make sense to people who aren't living it, why they might think that it would work. And so the definition, the word was created by Jay Forrester, who is an MIT systems scientist. And he was the one who went into organization after organization and discovered that people who know the system are often pushing the change in the wrong direction, which makes sense, right? Because we know how to do what we know how to do. So in a closed loop system, it's really hard to see what you don't know. Like, if you knew how to do it differently, we would do it differently. Like, it is often just, there's no process of discovery sufficient enough to help us uncover the blind spots, right? This is where the overfocus on productivity leaves no slack in the system. And our first idea is usually not the right idea. It's usually counterintuitive. That's great. If we have a little time, we'll figure that out. So I call this the pain train. Like, maybe you've been on the pain train, right? I have bridged the gaps, glued the silos, herded the cats, Like my job is to turn information into shared meaning, decisions, and impactful action. And as in all tech roles, but especially in systems architecture, I need to find a way to reduce the exhausting friction that is involved in doing knowledge work. Like when knowledge work is industrialized, it increases the friction in an invisible kind of way. And that in order to do change in the system, I need um, people to think, be able to think and act well together. I need different points of view. I need to understand what's happening. I need less Steve and more insight. And so the little thin slice of this that we're going to talk about is cultivating knowledge flow. And this is becoming a thing. I'm writing a book about it, which is sounds like a plug, but actually it's in the final for being on ThoughtWorks Tech Radar. And so right place, right time to be thinking about this subject. Um, and so let's talk a little bit about first what I mean, because there's a lot. This is like agile on steroids in terms of how different everybody's experience with these words might be. So the first biggest blocker is both defining knowledge and what do we mean by knowledge work? Because organizations pay knowledge workers billions of dollars for this work, but they're often then um, manage and controlling it towards productivity in a way that doesn't give them that return on on investment. So this isn't even something good for the people doing the work. It's also good and helps organizations, groups of people innovate and do the kinds of things they want to do. So knowledge work, I say, is practicing the generating, shaping, structuring, and sharing of meaning. Now, this is turning raw information into concepts, recommendations, diagnoses of what's going on, what is this bug, decisions, action, and code. So knowledge can be manifest in the Slack post, it can be manifest in code, it can be manifest in a whole bunch of different ways. The core of knowledge work is that, generally speaking, there's not one right answer, and there are a lot of questions. And so we're shaping and structuring and sharing information until we see what is a meaningful thing to do, what is a matterful thing to do. And what this does is it creates a knowledge system. It enables a group to do something more intelligent than any one person could do alone. This is a core of systems when you're always designing for emergence. But in my professional career, I think I talk business good. I think that I can make slides that say product words, and then I continuously discover I suck at it. Also, I make a lot of models, but nobody ever wants me on their Pictionary team. I am not a very good visual person, and at the same time, working on complex systems, if I didn't code it, I am not the expert on any particular part of the system. And so I absolutely have to rely on other people's expertise along with mine in order to have impact. I might have a great idea about how to make a monolith into an event driven system, and I might have all kinds of architectural answers. But if I can't get the budget, it's not going to matter. And partnering with people who speak money is helps both of us get that result. And so this is all the ways that people and machines co-create intelligence across situations, tools, and time, right? So this is how we generate organizational action. Everything running in production, I would say, is a knowledge object. This is a result of our ability of bringing together circumstances, tools over time to generate something that does something. So we focus on knowledge stock. That is our core when we think about knowledge. We measure the store of knowledge that you have developed or can access. Whiteboard testing, for example. Steve, remember Steve? Steve has a lot of knowledge stock. Knowledge stock is a great thing, and it increases your efficiency, right? The more I know about JavaScript, the faster I am at solving JavaScript problems. Not a big fan of JavaScript. I thought it was a fad for like 10 years. And so now I have to catch up because I'm a bit behind in my JavaScript skills. And there are 6 things that tend to block us, things that we've come to collectively believe that reinforce knowledge stock as what matters. So the first is knowledge is a static possession. If you win at Jeopardy, you have a lot of knowledge. You've stored knowledge. Also, we think of knowledge as what we put in a relational database, right? It can be quantified and it can be controlled. Knowledge is hierarchical authority, that knowledge trickles down from the top down to the bottom, that having authority means that you have knowledge. That knowledge is efficiency of execution. It can be, but when efficiency, throughput, and control are the ultimate markers of organizational intelligence, there's probably more to it than that. Being the fastest does not necessarily make you the most effective. Knowledge leadership is command and control. If you want something to get done, you make sure it gets done on time, on budget, and exactly the way that you had in mind. This type is, we've been to the moon, we invented iPhones. It's knowledge as extraction and domination. And sometimes, I mean, if you have kids, you know, sometimes the answer is because I said so. Sometimes that is what it is. But usually it is more likely that you have a system that can operate well without you having to command and control it. In nature, the healthy systems act with minimal need for executive control. There's always hierarchy in systems. It's about what that hierarchy is doing to enable the parts of the system to operate well. Knowledge is just delivery, meaning knowledge flow dead ends at delivery. Once something is out, it's done, and all the knowledge has been built. We've been to the moon, done. And knowledge is pure rationality. And the reality is that critical insights arise from diverse ways of knowing. And when we over prioritize data, logic, and rational argument, which are necessary for problem solving, we ignore that, like what Einstein said, which is he called it intuition, but it is basically all the other ways of sensing patterns in the system that are not strictly Vulcan ways of sensing them. So we need not to say that rationality isn't a core part of knowledge work, but it isn't the only part. So when you put all of these things together along with knowledge stock, you can see how hard it is to even start a good conversation about how to be more effective at the flow of knowledge. But it's very important, as Dave Snowden said, that the flow of knowledge is more important than the storage of knowledge. And this is especially true for me personally now. And anyone who is practicing domain-driven design is basically designing how knowledge and information and timing and events will flow through a system so that it can actualize its core domain in the best way that that system can do. And so we, without even really knowing it, domain-driven design gives us some of the skills like event storming that help us focus on knowledge flow. So event storming is basically a knowledge flow exercise. And it's the ability to transfer knowledge between people and technology. So the way that we structure an event stream, for example, in ways that change and shift the system. So this is where I say it's a difference between a pipeline and a platform. not just trying to get the river to flow from A to B. You're trying to have it flow in ways that shift the system so that it's more effective. Knowledge flow increases our effectiveness, right? Might not be as efficient, but it will have more impact. So in this realm, the definition, how I would define knowledge, is the shaping of time, energy, and attention into meaning, insight, and action. So it isn't just the code that we write, it's how we're able to bring our focus, our energy, our cross functional attention, how we're able to use those things, leverage those things to generate something that is meaningful and will actually make a difference. So, for example, I say often people are looking for a JavaScript developer with 3 years in they've used Next and React and 2 other examples, but they don't ask the question, what have you done with your JavaScript skills that has made a positive difference for the world, for your organization, for you personally? And because the average lifespan of a tech skill is 2.5 years, if you hire someone and they stay for 3 years, they will not be doing the thing you hired them to do. It be changing so fast. So it's the ability to do this regardless of what the tool set you're using is. But it also is the ability to develop skill with that tool set, which means knowledge flow is structuring time, energy, and attention into patterns that generate meaning, insight, and action. So it's causing effect as opposed to just fixing. So a single event can trigger time loops like reoccurring decisions. It can trigger delays and blockers. There can be an acceleration, like when we're having P1s and fire drills and have to run around like chickens with their head cut off because we have to fix things. And it can cascade in chaotic ways. One service begins to struggle, and we discover that 3 other services downstream now are also struggling. And so it's adopting practices that view time as part of what we're moving through, right? It's not make a decision here, deliver here. It's also the things that are helping us develop temporal intelligence, the understanding of how to work in a more asynchronous way, how to be in the chaos without trying to either make it not or get overwhelmed by it, which is usually where I am. So knowledge flow is AKA the system, right? Knowledge flow is the way that we design the socio-technical system that allows us to design a technical system. And it's both. And I am so sorry to be at this point in life where I give talks and workshops about this, because I miss the days when I was teaching intro to programming languages. Like I wish this wasn't so critical, but it is so critical, not just in tech, but in the world at the moment. So we're going to very briefly talk about a couple of what knowledge flow is, the truths about knowledge flow, but I want to make sure we stop to have time for questions. And so I'll say ahead that if you're like, yes, I agree, what do I do? You probably won't be as satisfied as you would be if we had more time to do this, but it is, you can take any one little tiny thing away and experiment with it, and you'll have an impact, because that's how systems work. It's that small tweak of a habit that scales to be the things that we do well or the things that we struggle with. So if you find one tiny little thing, that will be sufficient. So first is knowing that knowledge is emergent meaning, meaning knowledge isn't something we own. It is something that arises when parts of the system interact, when like for me and the business person get together and we create something neither of us could create alone. But it's also the same we're finding when you put AI in the loop. of an information system, you often get types of results that you didn't predict, but you can make use of, right? So knowledge is about how pieces of information in relationship can give you something different than what you imagined. Where we're going to focus briefly for a minute, because domain-driven design is on the context. Often we're being asked to do things and we have no idea why. Why does this matter? Or let's just do what Netflix does. Well, unless you are a streaming service that used to be a CD mailing company and have exactly the same technology skills and tech stack and the same exact culture, it won't work for you the same way that it works for them. It's always about the context. So here's an example of delivering value on shared context. So this is my office that Alita and I experienced differently. So Alita, I was solving the problem of walking on my keyboard and typing secret Slack messages to people and showing her butt in meetings as a bug. And so I bought a cat bed. Alita would like you to see the cat bed, because Alita found a cat bed, and that is the cat bed. And that the reality is that when I look at my office or I think about a cat bed, I have a particular point of view. For Alita, my notebook is way better than the comfy, soft thing. And so Alita and I together are trying to figure out the way to work together. And my first attempt at solving the problem failed. And she would be here showing her butt to you right now if I didn't put her out of the room before we started. So delivering value depends on understanding the core domain, like what is for FedEx fast package delivery, without exception. When I have tried to define the core domain with key stakeholders, organizational groups, I get different answers to the mission of the system, to what is the most important thing this organization does. One time in my career, and I just started working for them 3 weeks ago because I was so impressed, did I get the answer that was a domain answer and it was integrative one time in 25 years. And so context and knowledge flow depends on making a meaningful impact. And in order to know that, you need to understand the direction you're rowing in together. And so this is why the work of things like domain-driven design is essential to knowledge flow, because otherwise people are solving different problems and there's no cohesion. So knowledge is relational reciprocity. So reciprocity is simply exchanging with others for mutual benefit. In this case, this is what we do all day, right? We exchange ideas, we exchange solutions, we exchange we exchange cattiness. There's what do we do about Steve? But well-designed reciprocity is a core architectural skill. I depend on what other people know. I kind of don't have a purpose all by myself. Like, I need the fact that there's all these different perspectives. So I synthesize what the business is thinking about and product is thinking about with what the tech can actually do in reality, and try and make coherence, meaning a system where the people and the tools and the practices, the software, the outcome actually are impacting the domain. And this is more complex than when I get to put my headphones on and code, is to figuring out what to do. And so Steve shares opinions, right? Steve might be right. He has knowledge stock, but it doesn't help me understand the circumstances, or for that matter, Steve, right? It's a one-way street. Here you get. And we love opinions. We're a very opinion-driven culture. I have many opinions I'm happy to share with you. But when we're talking about knowledge flow, we're talking about helping to make each other's ideas stronger. I'm listening to you to understand where you're coming from. And is there something that I can contribute that will help you strengthen what it is that you're trying to do? which is very different from me telling you that looks like a graph and graphs don't scale. That's the stupidest idea I've ever seen. We haven't been able to do it. And if we can't do it, you certainly can't do it. Both are true stories of things that have been said to me about a recommendation. So ACOS says that a system is never the sum of its parts, it's the product of their interaction. And that is the what designs the system. If product hates tech and tech hates product, that relationship designs the software. And it's not like anything, it's not like nothing falls into the gap between the siloed teams that we make. Everything falls into the gap. If knowledge can't flow across teams, it flows and then falls down and gets lost. So being able to build bridges so that information can flow across the system between the people and within the tech, like needing to understand a transaction, for example, how a transaction works from the time a person arrives to buy something until the time that it's delivered to them, for example, is all the parts working together coherently, even though they might be separate. And so, because we're at, well, let's do this one. This is my favorite. That you think because you understand one, you must therefore understand two, because one and one make two. But you forget that you also must understand and. This is Donella Meadows, who wrote Thinking in Systems. It's one of my favorite things. And it is the art and science to me of architecting. It is not just understanding the one, it's understanding the impact of and. What happens when you put two teams, two people, two services, two pieces of infrastructure side together? What can they do? And that is where flow begins to happen. So I'm going to stop now. I will tell you that the two others I was going to talk about but didn't get to, but you'll understand them easily, is that knowledge is engineered through learning. I think this is a really important thing, that we're constantly learning, constantly having a growth mindset. 2.5 years. Peter Senge says, and it's my favorite thing, sharing knowledge occurs when you're genuinely interested in helping another develop new capacities for action, right? That this is when we pair, when we work cross-functionally, all of these things encourage knowledge flow. And the other is that there are many ways of knowing. So, for example, you have people in the room that are saying that we want to implement the new payment system in 6 months. Other people are saying we need to reduce cost per financial transaction by 20%. The architect talking about capabilities says this is about the capability to process transactions, and we need to reconcile transactions across bounded contexts. They're all talking about the same thing. They're just saying it very, very differently. And these different ways of knowing what needs to happen, when you take them all together, you're going to end up with a much better solution than implementing the new payment system in 6 months. You're going to deliver something that has much more comprehensive impact than the simple stated delivery model. And so go forth and knowledge-y. And then my last one, I'm sorry, Steve. If your name is Steve or you know a Steve, the Steve is an example, is actually a really great guy.